All right. So, hello and welcome everyone. We are live right now and welcome all of you to this amazing platform of Tutee Learning. So, we are back again on this particular platform of Tutee Learning, and today we're going to discuss the properties of definite integral, and along with that we are also going to look into different aspects of question that has been asked previously in the JEE Mains and Advanced questions. Okay. So today's class is going to be very important, especially if you are preparing for the upcoming JEE Mains and JEE Advanced examination. Okay. So keeping in mind the JEE Mains and the JEE Advanced examination point of view, we're going to solve questions and we're also going to see how you can apply those properties in different sets of questions. Okay. So I welcome all of you and let us start our today's discussion with the homework problem that I asked all of you to solve in the previous class, right? So if you're someone who is new to this particular platform and you haven't watched the sessions, then please, I request all of you to please go back to the channel description and check out the channel. In the playlist, you will find out all the lectures that has been taken so far on definite integral. So please try to follow the lectures on definite integrals, because if you don't follow the things step by step, you're not going to get the thing completely. Okay, so in order to get those things completely, you have to basically go step by step, and then only you have to build your base as well, right? So these all theories that I'm trying to talk about is going to build your basics. You're going to build a basic concept towards discussing or solving any questions of definite integral, especially in the examination, right? So with this particular idea, let's get started. Okay, so I hope you are all ready with this class, and thank you for joining on time. All right, so and also please share and like the video and share this video with your friends, relatives, or anyone who is preparing for the JEE Mains and JEE Advanced examination. This sessions is basically going to help especially students currently in class 11th and 12th. Okay, so please keep that in mind. And if you're someone from class 10th, 9, you can also watch this content if these things are making sense to you, right? So there is no age limit on attending these sessions, but these are specifically for JEE. Okay, so I will keep in mind that when I am discussing any question, I will always give reference or example of the JEE Mains and Advanced examination, right? So if you are preparing for any other examination apart from JEE, but whose mathematics syllabus is gonna the same as the class 11th and class 12 syllabus, then also you can attend these sessions and you can take the best use of these lectures. Okay, so with this particular idea, and before we start, another very important thing is that we have already started our one-to-one online tuition. Okay, so we are already doing on the one-to-one live online tuition, where you are basically getting the chance to study from teachers like me and our team, right? So you can always opt for that one-to-one teaching, and the number is basically given in the description of this particular live video. So please check out the description and you can find the number over there. Also, I will be providing the number on the screen. Also, I will providing the number on the screen so that you can contact us and me and my team on this particular number. So the number is 833-9827-528. So please try to contact us on this number in order to get any of your confusion clear regarding the online batches, how the batches are going to be like. And also you can opt for free demo using this part by contacting on this number. Okay, so based on your demo sessions or based on the demo class you had, you can always opt for like, okay, so I can go for this particular platform or not. Okay, so these are demo also the classes are basically offered, so please try to take the help of this benefit of these lectures and go through these concepts as well, right? Anyways, even if you have any questions like doubts, like okay, you might have missed the finishing the chapter, especially in your coaching classes, then also you can contact us in order to get your backlog coverage classes, which just starts rupees 49. Okay, so for your backlog covering classes or concept booster courses, it just start rupees at 49, very cheap, just less than 50 rupees. Okay, so please try to take all the benefit of these particular sessions and lectures that I am basically offering on this platform, and along with that, let's start with our preparation. So please take note down the number and then let's start, right? So the very first thing that I'm going to discuss in today's session is basically we're going to start the class from where I left it yesterday, right? So I said you to all to derive this particular relation, right? So what is the value of this expression? I asked all of you to find it out and let me know in the comment section. Okay, so let's see how many of you have tried or not. Okay, so the finally, so let me first of all reveal the answer, then I'm going to go into the derivation or the solution part of it. So the result of this both integrals should come out as, so if you have someone who has tried this question, the result of this both this question is going to come out as minus pi by 2 natural log of 2. minus pi by 2 natural log of 2. Okay, so this is going to be the answer for this question. I hope this is clear to all of you. Right, so let us quickly see how we can solve this question. Okay, so let us see over here how we can actually approach this question over here, right? So if I talk about the solution of this problem, so we know that both these integrals are the same, right, by the King's property. And so therefore, let us first of all take any one of the question and let's try to do it. Let's take the first one. So that is given from integral 0 to pi by 2 natural log of sine of x, right? So this is our question we have with us, right? So let's first of all assume this is the first equation, right? Now what I'm going to do is that I'm going to simply apply that particular property or the King's property, and I'm going to change this particular thing as 0 to pi by 2 natural log of cosine of x, right, or cos x, because if you do that complementary angle thing, that is sine of pi by 2 minus x is going to be equals to cosine of x, or sorry, okay, it is going to be cos of x. Okay, now and we have dx, right? Now, after we have this particular, let us call this a second expression or second equation. It is the first equation, this is the second equation. What I'm going to do is that I'm simply going to add first equation and the second equation. So if I do adding equation, so I'm adding equation 1 and I'm adding equation number with 2, right? So therefore, we will get, okay, when I add the equation of 1 and equation number 2, what I'm going to get is that I'm going to get 2 times of I is equals to integral 0 to pi by 2, that is I'm going to get natural log of sine x plus natural log of cos x, right? So I'm going to get this particular relation over here, right? Now we know that the base is the same, so therefore the summation of logarithm with the same base reduced to a multiplication, right? There is a simple property of logarithm, so therefore this particular will become the integral 0 to pi by 2 natural log of sin x multiplied with cos x dx, right? So this is a simple thing that you can do it, right? Now if we recall by a trigonometric identity or trigonometric relation, that I know that sine of 2x can be written as 2 times of sin x cos x, right? So I can write sine of 2x as 2 times of sin x cos x. So if I apply this thing over here, then I just need to add I just need to multiply with 2 and as well as divide by 2 as well, right? So therefore this relation is going to be like integral from 0 to pi by 2, it is going to be like log of 2 times of sin x cos x and then whole divided by 2, right? Now since whole divided by 2, I can also write this thing as, so I can take this thing as, okay, I can take this thing as minus of natural log of 2, right? I can write the same thing as minus of natural log of 2, right? Now after I have this expression, I'm going to reduce this form to I is equal to 1 upon 2 integration from 0 to pi by 2. This part is going to become equals to natural log of sine of 2x, natural log of sine of 2x, and then a minus. Now this part I can just simply separate it out and integrate it. So this natural log of 2 will be the constant, and integration of dx from the limit 0 to pi by 2 is going to be equal to 5 upon 2, right? So I will have this expression over here, and don't forget there is a half over here as well, right? So I have this particular expression over here now. Now the important part over here is to change it. Now we know that this integral is basically log of sine x, right? The integrand part is log of sine x, but we have over here as log of sine 2x, right? So that is the most important part. Okay, I forgot to write the dx over here. Okay, so this we have log of sine of 2x, right? Now what I'm going to do over here is that after I have this expression, let us assume, so I'm going to assume this is my another integral. Okay, I'm going to assume this is my another integral. Let us say I1. Okay, let us say it is I1, and in order to solve this integral I1, what I'm going to do is that I'm going to let 2x as some variable t. I'm going to let 2x as some variable t. Right. So if I do this substitution, then this particular I1 can be given as 0 to. So instead of having like, now x is basically the variable limit is basically in t, right? So the when x equal to 0, t is equal to 0, but when x equal to pi by 2, t should be equal to pi. T should be equal to pi, right? And then we'll have the remaining expression as same, that is log of sine of x, or I should, anyways, it doesn't matter. Okay, you want to put t over here is the same, right? So we have this expression. Now remember that in the last class we discussed about another very important property of changing the limit of the integral to its half, right? So then I can write this as 2 times of integral 0 to a function expression of f of x dx if and only if I have this particular condition, if and only I have this condition, that is f of 2a minus x is equals to f of x. Okay, so if I have this condition f of 2a minus x is equal to f of x, then only I can do this particular form over here, right? So if I change this, use this property over here in this question, then this particular thing is going to be equals to, now since I know that sine of pi minus x is going to be equals to again sine x, right? So therefore this I can change it to sine of t dt, but this will be 0 to pi by 2 and 2 times of it, right? Now if I just plug it into back into this equation over here, so therefore now the interesting part is that now I1 becomes 2 times of I, right? So therefore if I plug it back into this equation, I is equals to, so I will get over here, that is my I is equal to, okay, let me check, uh, or I can do is 2 times of I is equal to, okay, I think I did a mistake. Okay, yeah. So the mistake is that when I put over here, it should be 2 times of dx is equal to dt, right? So I forgot dt by 2, right? Dt by 2 times. So this will be I by 2, which is again going to be equal to I, right? So therefore, I is equal to, now I1 becomes I, right? So therefore, I is equal to I by 2 minus pi by 4, natural log of 2, right? So I will have this expression over here, right? So let us now simplify this, and therefore on simplification this thing will become I by 2 is equal to minus of pi by 4 natural log of 2. Therefore I will become minus of pi by 2 natural log of 2, so therefore this is going to be the answer to this question. Okay, I hope the solution is clear to all of you, right? The solution is clear to all of you, right? I hope the solution is clear. This is a simple solution. Okay, just try to do the things step by step and try to keep on applying the properties as you're moving along with the question. Okay, so the answer to this problem is finally going to be equals to minus pi by 2 natural log of 2. I hope this is clear to all of you. Is this clear? Please give me a thumbs up or say yes or no in the live chat. Please let me know yes or no in the live chat. Yuvraj Singh, hello. Amol Gupta, very good. Pi by 2 minus pi by 2 natural log 2. Very good, Amol Gupta. Anmol Gupta, very good. Okay, so I hope this is clear to all of you, right? So I can also see in the live chat that you are basically able to answer this question. So that basically makes this that the idea and the concepts are clear, right? And I would recommend all of you to please keep this result handy or try to remember this result, because this is going to be very, very useful, especially when you're going to solve bigger part of a problem. Okay, so you're going to see these kinds of problems a lot. Okay, so I hope this is clear to all of you. Let's proceed with the problem solving. Okay, let's proceed with the problem solving. We're gonna see now before okay, now quickly before we proceed for another problems or question solving sessions. Okay, I want to quickly dive into one or the other important property, that is, what if I have a variable limit and I want to change that particular limit from 0 to 1, right? So this is also a very important property, and it is also helpful sometime. Okay, the property, okay, the what does this property talks about? So this is going to be the property number 7, and this property talks about that if I have any integral from a to b for the given function f of x dx, then I can write this expression as b minus a integration from 0 to 1, functional expression of b minus a times x plus a and dx, right? So what I'm basically doing over here is that I'm trying to change this limit from a to b to 0 to 1. Okay, now it might be a very important necessity, because sometimes we need to change the limit so that I can make it from 0 to 1, so that I can easily get the answer, or quickly I can get the answer, right? So sometimes these kinds of properties actually help our problems to make it easier, right? I won't say this is a very important property, but it sometimes helps us to solve the question quicker. Okay, so how can I prove this property over here? I can quickly see a proof. Okay, now this is a very simple thing to prove. Okay, suppose we have this integral from a to b f of x dx. Okay, How can I prove this? So it's very easy. Okay, that we need to change the limit from a we have the limit from a to b. We need to change it to 0 to 1. So let us say that I want to change the limit from a dash to b dash, right? So what actually means when we are doing the change of limit, or when we are basically changing a variable in this problem, what we actually mean is that we are transforming to a different axis, or something also called as a Jacobian, right? So the similar thing when you do for multiple integral, which I haven't covered so far, right? But later in university, when you discuss our multiple integral, when you transform a particular variable coordinate to another variable coordinate, you need to multiply also with a Jacobian, right? So similar thing you're basically doing over here. When you're changing the variable, you're basically trying to transform that particular axis to different axis system, right? So what we are doing is that if we want to change the limit from a to b to this coordinate domain, that is a dash b dash, to this a dash b dash. Okay, doesn't mind if I put like a open bracket or close bracket. Let's okay, keep it a close bracket. Okay, so if I want to change this particular interval to this particular interval, as x varies from a to b, we need a new variable. Let us say for this the variable is t, and for this the variable is x, right? So what I'm doing is that I'm trying to change this x to this t such that when I'm transversing x from a to b, the t should transfer from a dash to b dash, right? Now how I can achieve that? It's very simple. I can try to do it by simply plotting the see a graphical thing. So I'm trying to plot from x to t, right? So when my x is equal to a, my t should be equal to a dash, and when my x is equal to b, my t should be equal to b dash, right? So this is my idea, what I'm trying to do over here, right? Okay, now, so let us try to draw a linear variation from A to B, right? So what I'm trying to do is that I'm trying to linearly get out the value of the t for which I'm getting this particular condition satisfied, right? How can I do that? It is very simple. I can try to use the relationship between the slope, right? So what I'm going to do over here is that I can write t minus a dash upon x minus a, t minus a dash upon x minus a is equals to b dash minus a dash divided by b minus a. So I'm basically equating the slope. Okay, I took up any random point, so random point will be given as x comma t. So I took up this particular slope and I equated with the slope of the given line over here, right? So I hope this particular thing is clear, right? It's a very simple thing when we have any straight line, right? This is a basic property of straight line. So after we can have this result over here, I can write my t as a dash plus b dash minus a dash divided by b minus a multiplied with x minus a, sorry, okay, multiplied with x minus a, right? I hope this is clear. Now after I have this particular transform, so what I'm going to do is that I have what I was doing is that I'm trying to change the variable x to t such that my condition is satisfied, and I got my condition satisfied for this particular value of t. If I take the t and x relationship as something like this, then I'm going to satisfy my variation, right? Now after over here, now what we do in substitution is that we basically differentiate both the side. So our dt is equals to b dash minus a dash divided by b minus a, right? And then we have dx over here. So therefore, if I do this substitution, then my integration from 0 to a to b for the function f of x dx will be equals to integration from a dash to b dash for the for the given function, that is like f of a dash plus b dash minus a dash divided by b minus a times x minus a. Okay, and then in place of dx we're gonna have like, so okay, let me check. Okay, I did a mistake over here. It should be t minus a, right? It should be t minus a, right? Yes, it should be t minus a. Sorry, t minus a dash. Okay, I completely took the reciprocal. Okay, okay, so this b dash and a dash part will come in the denominator over. Okay, so after that it is going to be dt. It is going to be dt, and then okay, I should also separate this. Okay, otherwise it's going to look like very same, right? So I'm writing over here dt and then multiply. So don't forget dt should be equals to b minus. So I'm transposing dx to dt, right? So dt will be b minus a by b dash minus a dash into dt, right? So this is the dx part. This is the dx part, right? I hope this is clear, right? So therefore, I am able to transform my variable x to another variable t for which I am satisfying the given requirement, right? Now in this case, I want my So this can be done for any general thing, any general. For example, you want to do it transformation from -1 to +1. Then you can put a dash as -1, b dash as +1. So I'm showing you for the general case. And now our requirement was a dash should be 0 and b dash should be equal to 1. So if I do that as per the requirement, then this particular function expression f of x dx from a to b can be given as, now this particular part. So a dash and b dash, which is equal to 1, and b minus a is a constant, so this will come out. So b minus a will come out, and my integration is going from 0 to 1 for the function expression. Now a dash is equal to 0 and this b minus a, so it is going to be b minus a into x, right? B minus a, sorry, I'm doing again a mistake, t, right? T. Okay, so b minus a into t plus a, okay, plus this constant a is gonna come out, right? So I hope this is clear. Okay, I think I did a mistake. It should be a only, not a dash. Okay, yes. Then it will be a over here, right? Okay, then I have dt over here. Now I can always change the variable, that doesn't matter. Okay, unless I can change the variable dt to again x, and this will be b minus a integration from 0 to 1 functional expression of a plus b minus a times x into dx, right? So therefore, I am able to transform this particular limit of the integral from a to b to 0 to 1. Right. So this is a very important aspect, especially of learning the properties, that I can transform my integral limits to different limit interval, right? So depending on that, I can also have a variable substitution, right? So I hope this particular step is clear. And why did I wanted to discuss about this step? Because it is very useful, especially in question when you want to get the answer very quickly, right? So sometimes it will help you. So mostly, for example, if you can transform this particular function to this particular function where it is kind of seeing that you are getting the advantage of even an odd property, then you can do it from -1 to +1, right? So that question actually help you a lot of time. Okay, so I hope you will take the best advantage of this particular properties and look into the and use your ideas to basically solve different questions. So okay, so I hope this idea is clear to all of you. Please let me know in the live chat, is this clear or not? Is this theorem clear to all of you? Is this property clear? Please let me know in the live chat. I'm going through a live chat. Please let me know, is this property clear or not? Okay, so I gave you the proof of this property. Okay, and you can use this property as and when the need arises. Okay, so with this, we are basically ready to now start with the discussion about the periodic function, right? So we're gonna solve question as well. Okay, we're gonna definitely solve question as we are going on with the lecture, but let's quickly start with the periodic function. Okay, because I have to also take on with the lecture, because I'm planning in this way that I basically will have a session especially dedicated to problem solving only. Okay, so once the chapter is done, once the integral portion is done, so once I cover a big chunk of the chapter, then I can plan with starting with the question solving session. Okay, and in that question I'm going to take up all general types of question that has been asked so far in JEE Mains, JEE Advanced, or any other competitive examination, even Olympiad question as well. Okay, so I'm going to take up all those questions and put up on this particular platform. So don't forget to subscribe and hit the bell icon so that you never miss out any update whenever we are basically live on this particular platform. Okay, so with this, let's quickly go on to discuss the application of di to periodic function. Okay, di means definite integral to periodic function. Okay, so let us quickly discuss about the periodic function. Okay, now in this particular session I'm going to cover the basic property of the periodic function, and in the next upcoming session we're going to discuss the other important question as well of periodic functions, right? So if I quickly talk about what is periodic function, you all know it very nicely that periodic function, if I talk about f of x is a periodic function, then this particular function should be having a repeated interval. Okay, if it is a periodic function, if it is a periodic function with a period, let us say the period is basically t. Okay, let us say the period is basically given as t. Okay, so then I know it very nicely that the function of value will gonna be repeat again after this interval t. So the function of value at f of x plus t should be equal to functional value at x, right? So I hope this is clear to all of you, right? Is this clear to all of you? Similarly, I can keep on going any types of interval like x plus 2t and so on, right? And ultimately the answer is going to be same. So function of value of x plus n times of t also is going to be same as f of x. I hope this thing is clear to all of you, right? So this is basically about the periodic function, right? So once we know about the periodic function, now my task is basically to repeat as. So the first property is that, now it is a very trivial property, is that if I am integrating any function from 0 to m times t, m is an integer, for the function f of x where this period is t, then I can write this simple expression as, instead of integrating from 0 to m times t, I can just integrate from 0 to t and multiply with m, because again the functional part is again going to be repeating, right? So it is the same area. So instead of finding out all the area separately, just multiply with m. That's it. So m times 0 to t for the same function f of x dx. Okay, so this is the most trivial property, especially when we are discussing with periodic function, right? So let's now take up the other properties as well. Okay, now let us discuss about the properties of the like what happens if we have a constant involved with the period of the limit, right? So let us quickly discuss about this. So let us say, and I'm going to prove this by help of a simple example. Okay, so let's take an example first of all. Okay, so the example I'm going to take over here is that, let us take an example of a periodic function, and a very interesting periodic function is simply sin x. Okay, sin x, and the period of this sin x is basically, we all know it is 2 pi, right? So sin x, the period is basically 2 pi. So let me write the period over here. The fundamental period is basically 2 pi, right? Now, if I want to find out, now it is a very important result. Please remember this, okay? When I integrate from 0 to 2 pi for sin x dx, this result, so when I integrate this result from 0 to 2 pi, you know it, the curve is like this, right? So at pi it is going to be 0, and at 2 pi again it is going to be 0, right? So interesting part is over here is to follow is that when you integrate from 0 to pi, the result is going to be equal to 0, okay? Because this particular area is going to be equal to this particular area, right? And what is the value of this area? So if you integrate from 0 to pi for the function sin x dx, the result is equal to 2. Okay, so please keep this result in mind, because it is a very useful and important result. Okay, this is a very useful and important result. Okay, now if I quickly talk about, let us say I, instead of having the limit interval from 0 to 2 pi, let's say I take up any constant value, something, let us say a. Okay, and I want to start my integration from a to the interval a plus 2a 2 pi, sorry, a plus 2 pi. Okay, I want to integrate, instead of integrating from 0 to 2 pi, I'm integrating from some particular length of a to a plus 2 pi, right? So what I'm doing is that the stretch of the, or the interval I'm taking for the for the upper limit and the lower limit, the interval is remains the same, but I'm changing the lower limit to some constant value. Okay, or I'm shifting, or I'm shifting it. Let us see what happens if I do that particular modification. Then the interesting part is that even if you shift it, so the area over here, this particular area, so let me use a yellow, white color to repeat. So this particular area that you are basically getting extra, okay, this particular area that you're getting extra will be compensated by this particular area, right? So instead of going from a to a plus 2 pi, why don't you go from 0 to 2 pi? Right. So if you just shift the interval remains the same. So if when you're shifting the interval must remains the same, then you can have the same value of the limit by changing the interval as well. So what I'm trying to repeat is that if I have from a to a plus 2 pi for sin x dx, this result is again same for 0 to pi, 0 to pi sin x dx, right? So this is true for any general periodic function. That is, if I have any general periodic function like this, like integral going from a to a plus t, where t is the fundamental period of the function f of x dx, then for the function f of x, then this can be when going from 0 to t, 0 to t for the function f of x dx, right? Now I can have multiple modification to it. I can add this and combine this as, and I can write this as n times of t. Then I can have to just multiply with it. That's it. Simple relation as it is. Okay, simple and short, right? So I hope this is clear. Now similarly, I can have multiple modifications, saying that I can also add the fundamental period, some other multiple of fundamental period to some other multiple of fundamental period over here. That also I can do. That is, what I mean to say over here is that if I integrate from a plus n times of t to b plus n times of t. Now what is more important to notice over here is that the fundamental period addition in both the limit, or the both the interval, or the both the lower limit and the upper limit is the same. Therefore, you are interestingly only getting the area it is equivalent to only getting the area between A to B. Okay, only between A to B. I hope this is clear. I hope this is clear, right? So instead of finding out the limit from A plus NT to B plus NT, it is equivalent to finding out the limit from A to B. That's it. I know you can always try to think about this result when you try to think of the simple example that I took of sin x, right? So you can always take a simple basic example of periodic function. I can try to get to the relation, right? But one more interesting modification can be done over here. So let us say one constant A and the other constant B. Then I'm taking some another fundamental period n times of t for the function or the periodic function f of x, right? So this can also be given as, so let us now split the limit. Let us first go from A to B f of x dx and then n times 0 to t for the function f of x dx. Okay, so this is all the different types of modification I can do, especially for periodic function. I hope this is clear to all of you, right? Please let me know in the live chat, is this clear? Rosie, 2 pi, how long will this be? This is basically a 1 hour class, okay? I hope this is clear to all of you, right? Is this clear? So these are all the important properties, especially related to the periodic function. Okay, so I hope these things are clear. So whenever we apply the questions, okay, you can see that how you're gonna apply these things to the question. Okay, so in order to help you out in solving question, I want to first of all give you some question to practice. Okay, so the very interesting problems I'm going to give over here, and we're gonna start our next class discussion just from this particular question itself. Okay, so let me give you some homework problems so that you can discuss on it and you can think about it, how you're gonna apply these properties, right? So let us say the first question, 0 to, the integral is given from 0 to n to n pi, and the function is given as sin x plus cos x, and you know sin x plus cos x, the fundamental period becomes, try to find it out. Okay, what happens when I have the addition of two periodic function, what happens to the fundamental period? Okay, so try to solve this question. Okay, oh sorry, and then we have a greatest integer of it, and then we have a greatest integer of it, right? So this particular square bracket denotes greatest integer function. Okay, I'm writing in short, GIF basically stands for greatest integer function. Okay, so please try to find out what is the result of this first problem. Secondly, now you know that that greatest integer function are also periodic functions, so that is why I give this question in this particular sense. Okay, okay, and let me take one more important question. Let us say you want to integrate from 0 to 25 e to the power x minus greatest integer of x. Okay, e to the power x minus greatest integer of x, that is in the exponent. Okay, so try to find out this particular question as well. Okay, so these are the two useful questions that will actually help you to learn about applying the periodic property or the properties related to periodic function. Okay, so please try to solve these two questions before you come to the next class that is going to happen tomorrow. Again, we're going to meet live exactly at this particular timing. Okay, or maybe a bit of different timing, but keep following the channel. Okay, so please hit the bell icon so that you get the notification instantly when I am live on this particular platform. Okay, so that you don't miss out any content of this channel as well. Okay, so I hope this is clear to all of you. And with this, we are going to start with the most fundamental also theorem of the definite integral, that is the Leibniz rule for differentiation under the integral sign. So that will be our motto of discussion for the upcoming class. Okay, so in the next class when we're going to meet tomorrow, we're going to discuss about the Leibniz rule of definite integral. Okay, Leibniz rule for definite integral, how do we differentiate a integral function or variable limit integral, right? So that is our motto for the next class, and after that I'm going to discuss about the Wallis formula, right? Also we're going to talk about the recursion formula, right? So that I can incorporate in the Wallis formula thing as well, right? And then also we have to solve questions of limit as a sum of infinite series, right? So that is also a very important question, how we're going to change the question of limit of sum to definite integral, right? So stay tuned for that. Okay, and please subscribe the channel. Okay, and I request all of you to please subscribe the channel and please hit on the like button so as to provide an appreciation to all this particular free content that I'm trying to provide on YouTube, right? And also share these videos among your friends, your juniors, okay, as well as your relatives who are basically preparing for their JEE Mains and Advanced examination, so that at least they can take advantage of this particular free lectures and then they can prepare for the upcoming JEE Mains and Advanced examination. So with this particular thing, I would like to conclude my session. Okay, I hope this session helped you a lot in understanding the basic of the definite integer properties. And once we are done with the basic understanding of the definite integer properties, we are going to definitely start with solving a lot of questions. Okay, so stay tuned for the question session. So we're going to definitely take up question solving session very soon, okay, on our channel itself. So please subscribe to the channel and click the bell icon. Okay, so with this note, let's end our session over here. Thank you.